This video is all about transversal algebra, so we're going to take what we already know about parallel lines and transversals. We're going to apply all of our vocab words to solve for missing angles. So I'm going to start by identifying some sort of an equation I can use. Well, it looks like I have two angles going on right now. I've got a 13x and I've got a 23x. Yes, there are other angles in this picture, but I want to get x into play somehow. So you're going to ask yourself, what type of angles are these? Well, they are on the same side of the transversal, so they are consecutive, and they are inside the parallel line, so we call these consecutive interior. Consecutive interior angles are supplementary, so these two angles should add together to be 180. If you don't remember that vocab, or you don't remember the fact that consecutive interior angles add up to 180, you can usually guess just by looking at the picture. It looks like I've got an acute angle and an obtuse angle. And with our relationship of parallel lines and transversals, the angles will always either be equal to each other or they'll add up to 180. So there's no way an acute angle is going to equal an obtuse angle. So rather than being equal to each other, these two things will add up to be 180. So if I were setting up an equation, it would probably look something like 13x plus 23x equals 180. 13 and 23 would be 36x equals 180. And x would be 5. So we're trying to solve for all of the angles. Now that we know x, we can pretty easily find two of the angles. So 13 times 5 would be 65. So that angle is 65 degrees. 23 times 5 would be 115. So this guy is 115 degrees. And then from there, we have to solve for all of the other angles. But it's actually not that hard. You probably know already, once we have two angles, two different measures between parallel lines and transversals, we can figure out all of the other angles. We know vertical angles are going to be the same. So this guy would be 115. This guy would be 65. And then we can work with supplementary angles. We know 1 and 2 should add up to be 180. So this guy would be 115. So you'll notice that all of your obtuse angles in this picture are going to be the same, and all of your acute angles in this picture are going to be the same. All right, let's work out a similar example. So I'm going to start by setting up some sort of an equation. It looks like I have an expression up in this corner and an expression down in this corner. So we should probably try and use those two somehow. Those two angles are on opposite sides of the transversal, and they are outside. So we call those alternate exterior angles. You could look up, if you don't know, if alternate exterior angles are congruent or if they're supplementary. But again, you can usually tell by looking at the picture. I have two acute angles here. So my two acute angles will always equal each other. If I were looking at two obtuse angles, say 3 and 5, my two obtuse angles would always equal each other. So the equation I can make would be 4x minus 45 equals 2x plus 15. We can do this algebra. I'll subtract 2x on each side. So give me a 2x on the left. I'll add 45 on each side. So that would give me 60. Divide each side by 2. X would be 30 here. And then we wanted to solve for all the angles. So it looks like both of these are acute, so they're going to be congruent to each other. So I really just have to figure out one of them. Let's do this one up here. 4 times 30 would be 120 minus 45 would be 75. So this angle is 75. Vertical angles are 75. All of my acute angles in this picture will be 75 degrees. And then we just have to find one of the obtuse angles and we'll know them all. I'm going to use the fact that angle 1 and angle 2 are a linear pair. They're supplementary. So to find angle 1, I would do 180 minus 75 gets me 105. And then I know all of the other obtuse angles in this picture. So this one's a little bit trickier solely based on the fact that this picture doesn't look like the pictures we've been looking at, but we do still have parallel lines in it. Notice that this line and this line are parallel. They're marked by those two arrows. And I could say this line down here is a transversal. So that tells me that 14y and 16y are on the same side of the transversal and they're inside the parallel line. So these two are consecutive interior angles. Once you figure out what they are, ask yourself if they're equal to each other or if they add up to 180. And again, you can usually do this just by looking at the picture. It doesn't look like those two angles are equal, so they're going to have to add up to 180. So my equation to find y would be 14y plus 16y equals 180. 14 plus 16 would be 30. Y equals 180. And 180 divided by 30 would be 6. So y would be 6. And then to find x, we'll do the same thing. We'll look for some parallel lines. Well, we're going to use the same parallel lines we used last time. This line and this line are parallel. And this line transverses them. It's a transversal. Well, 6x and 9x are on the same side of the transversal. And they are inside. So they are consecutive interior angles. Ask yourself, do those two angles equal each other or do they add up to 180? It does not look like they are equal to each other, so they add up to 180. 6x plus 9x equals 180. 15x equals 180. 180 divided by 15 is 12.